Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And before we dig into tonight's lesson, just go out and buy a kid a book. I've said this many times. Here in the Philippines, a lot of children don't have books in school. So I'm not saying buy them for here. If you want to, that's fine. But wherever your local school is, wherever your neighborhood school, just support the kids there. Just whatever needs those teachers have, let's support them in trying to educate our children. And together, then we sure enough can build a better tomorrow and do that through math or science, any STEM, English, whatever it happens to be. Tagalog, Chinese, Pakistani, it doesn't matter. Our children are the ones that's going to run the world tomorrow, and we want them to be good sound mind, make good logical decisions so that the world can be better. Okay. All right, let's jump into the lesson. We have along the theorem, the theory of where did he get that formula. Let's look at this integral and see how we can utilize various tools to end up with a pretty good formulation here. All right, we have the integral of x times the square root of x to the fourth plus 4 dx. What to do? Well, we have an x I'd really like to get rid of. That complicates this. So let's rewrite this as the integral of x times the square root of x squared squared. That would give me x to the fourth plus 2 squared dx. Okay, I'm going to let a, recall the formulas now. If we're looking at this, this looks a lot like tangent. So if we manipulate this, okay, we can get rid of this x. So let's let a equal 2. So we have a squared. Okay, let's let u equal x squared. And now let's rewrite this integral. We have x times the square root of u squared. U is x squared, so that's in the parentheses there. U squared plus a squared. Okay, and we've got to get du here. That's 2x dx, because we need to replace this dx. So I have du divided by 2x equals dx. So now I have du, replacing dx here, du over 2x. That x and that x cancel, and that's what I wanted here. Let me pull that 1/2 to the outside. So now I have 1/2 the integral of the square root of u squared plus a squared du. And you may be thinking, well, am I any better off now than I was before? Well, let's see. All right, I'm going to rewrite u. Let's let u equal a tangent theta. How about that? Okay. What does that mean? Du then is a, that's constant. The derivative of tangent theta is secant squared theta. Chain rule, d theta. Okay, so now this du could be, well, it's du. Du equals this. I've started to go ahead and divide. No need. Okay, so 1/2 the integral of the square root of u squared. So I have a tangent theta squared plus a squared times du, and that equals a, and I'm going to pull that a over here, secant squared theta d theta. All right, let's go ahead and square what's inside here. So I have a squared tangent squared theta plus a squared times secant squared theta d theta. Okay, I think I can do this one more time here. A over 2 times the integral of the square root of, I'm going to factor an a square out of this, a squared times tangent squared theta plus 1 times secant squared theta d theta. All right, let's go up here. We'll come up here, work. We have a over 2. I think I'll just rewrite it so we'll have it all in front of us. Integral of the square root of a squared. Actually, I'm going to go ahead. Tangent squared theta plus 1. We could write that as secant squared theta. I'll do that. And that's times secant squared theta d theta. Okay. Now then, let's take the square root of a. So the square root of a squared, not a, but square root of a squared gives me a. That a times this a would give me a squared over 2. The integral of, what's the square root of secant squared? Secant. So I have secant theta times secant squared theta, which would give me secant cubed theta d theta. Oh, you recall in a previous video we said the integral of secant cubed is one of these things we need to be just put in our memory because it pops up from time to time. So a squared over 2, the integral of secant cubed theta is 1/2 secant theta tangent theta plus 1/2 the natural log of secant theta plus tangent theta. Well, let's see here. What was a? A was 2. So if I take this a squared over 2 times 1/2, that gives me a squared over 4. 2 squared is 4. 4 over 4 is 1. So this term goes away. And then as I multiply a squared over 2 times this one, that term goes away. So I'm just going to erase those, get them out of the way, save some space here. So now we have secant theta tangent theta plus a natural log of the absolute value of secant theta plus tangent theta. Okay, so what is theta? How do we get that guy? Well, if we back up to here, we had u equals a tangent theta. Now I know I've renamed u as we went along, but right now u equals a tangent theta. So if u equals a tangent theta, u over a equals tangent theta. So if I have a triangle and I have tangent is u over a, well, what was u? If I go all the way back up to the x world, u was x squared. So I have x squared over a, and a was 2. So what does that give me here? If I have, looking at this hypotenuse, oh, that's a big word, x squared squared, which would be x to the 4th, plus 2 squared, which is 4. The square root of that sum would give me the hypotenuse. Okay? All right, so let's keep rolling here. So now secant theta, and this is theta, by the way. Secant theta, or cosine is the adjacent over hypotenuse, but in the case of secant, it's the hypotenuse over the adjacent. So we have the square root of x to the 4th plus 4 over 2 times tangent, which is x squared over 2, plus the natural log of the absolute value of secant. Again, it's the x to the 4th plus 4, that square root of that, over 2, plus tangent, which was x squared over 2, plus c. That would be your answer. And that, my friend, is that integral. It looks like it just got larger, didn't it? Okay. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. So keep studying, guys, and buy a kid a book. Link up with your local school and try to help these kids, okay? All right, that's all for now, and we'll talk to you next time. Thanks.